is, by you enabling DNS security extensions, DNSSEC we call that, which is a suite of security protocols pertaining to DNS, you validate that your DNS server is only going to replicate data to those DNS servers that have been properly authenticated. So that means DNS servers have to have appropriate authentication protocol. This is not encryption protocol, this is authentication protocol. That means one DNS server says, this is my ID, and here is my security token. The other DNS server says, okay, your ID, this is a token, the exchange. Once they agree, and once they are listed as authorized within their database, then they can start exchanging actual data. Another best practice as far as DNS is concerned is that within any corporation, you want to make sure your internal DNS servers communicate only with root name servers. I talked earlier about the fact that DNS is a hierarchical system. Hierarchy from www, which is a computer name, to the domain name, to the top level domain, and after top level domain comes the root. You only want to make sure that they can communicate with root servers, because this way, your internal servers are not going to communicate with any other external servers, causing an issue. So here is a practical scenario, and I do talk about this in my course as well. Your security team determines that someone from outside a company has obtained sensitive information about your internal organization. How? They queried the company's external DNS server. And guess what? On that external DNS server, there were not only records for external hosts, there were also records for internal hosts. And that's a bad practice. The way you address this, you implement what's called a split DNS server. I should actually have said DNS server infrastructure. That means a separate DNS server hosting a zone for our outside hosts, a separate DNS server and DNS zone for our internal hosts. And they do not share information. This way you keep the authoritative records secure for each respective zone. Let's talk about this man-in-the-middle attack. Man-in-the-middle attack essentially means let's say I'm a hacker. I could persuade either a user or even a wireless access point, AP, to believe that, hey, that user or that access point is talking to a legitimate one, whereas in fact, this one is a rogue, is a fake. The reason I brought a wireless access point is man-in-the-middle attacks are quite prevalent in wireless networks. And wireless networks are popping up everywhere. You go and turn on your machine in your neighborhood, you take a look how many other tenants, how many other homeowners have already activated their own wireless access points. So with this man-in-the-middle attack, MITM, we have a variety of it called replay attack, which means the rogue user plugs into the network. It receives the data from point A, the source, massages the data, makes a copy of it, makes modification to it, and then replays it and puts it back on the wire. Sometimes, for those who are doing passive attack, they just receive the data, take a copy of it, and then put it back on the wire. Nobody knows that this had happened. In the case of active, which is a worst scenario, not only copies the data, but it also modifies it and then replays the data across. So what do we do to stop this attack? We use cryptography. Cryptography or encryption. Cryptography, by the way, happens to be a Greek word and essentially means we make whatever data we have unknown to the other side, not make it available to the other side. And the way this is going to happen is sometimes if you don't want to use cryptography, you want to make sure both sides negotiate between themselves some kind of a random key, a key that is only going to be good for the duration of the conversation. Once that communication is completed, we dispose of that random key, is no longer good. We generate new keys next time around. A way to avoid man-in-the-middle attacks is to timestamp all messages. And any messages that fall outside a reasonable amount of time, window of time, or normal window of time, what we call, we just simply reject them and drop them. Okay, as far as man-in-the-middle attacks are concerned, there are 3 additional attacks that you need to be aware of. And 2 of these I talk about in my course. ARP poisoning. ARP stands for Address Resolution Protocol, which is a way that a IP address is converted into a MAC address, the address that's on each network interface card. ARP poisoning essentially means that some hacker can go there and replace a legitimate IP address with its own MAC address. So any communication that was supposed to be directed to a legit machine instead is going to get redirected to the fake machine. This used to be prevalent in IP version 4. As software has got updated and as IP version 6 is becoming more prevalent, our poisoning issue is disappearing. By the way, I just mentioned IP version 6. Some statistic that Google had published says that we are using about 20% of the word or 20% of the communication directed to google.com. Their search engine is running on IP version 6. DNS poisoning essentially means we poison the records within our DNS database. Instead of pointing to legitimate hosts, we point them to the fake or the hacker's machine. And last but not least, privilege escalation talks about, hey, I want to be able to upgrade my privilege instead of being a regular user, become an administrator or a security administrator. Let's talk about denial of service. DOS is a kind of an attack. And in fact, believe it or not, back in 2003, I remember that because I wasn't involved in it. I suffered through it. Microsoft suffered a denial of service. Back then they had Windows XP and Windows Server 2003. And they had not followed a lot of good practices that they're doing right now. The whole idea of DOS attack is an attempt to prevent legitimate users like you and me from using a service or using a device. How? They flood the network or they flood a device with illegitimate traffic. And a worse situation than DOS is DDoS, which is distributed denial of service, which means it's happening from multiple locations. And essentially through DDoS attacks, your servers are flooded, your networks are flooded, your end user systems receive tons of useless traffic, CPU utilization pegs at 100%, legit users can no longer gain access to these resources. And essentially what happens is that it could be that your machine becomes infected, your machine becomes compromised. A compromise means a machine that is infected, and that your machine in turn sends up more junk stuff, useless packets to others. And an example of this DOS is the SYN flood attack. Typically for any TCP/IP communication, we have a 3-stage. SYN is a synchronization, ACK is an acknowledgement, SYN plus ACK to indicate that, okay, from this point on, we are ready to proceed and send data. By SYN flood attack, you essentially flood the 2 endpoints with these useless packets. So how do we defend against this? First thing you have to do is to be able to identify where these attacks are coming from. Then you need to make sure you enforce security policies for resource consumption. Resource consumption means I want to make sure if the CPU goes above 80%, that's not allowed. Maybe we highlight, send an email to someone, send a beeper to someone, beep somebody, send a text message to someone, or in our system management tools, we have a message pop up in the middle of our SNMP screen, for example. You want to make sure you have proper backup resources available. Notice I keep talking about the backup again. You have to be continuously monitoring your network for suspicious patterns of behavior. Guess what? Because cloud providers have so much in reputation, this is one of the things they have to do to monitor their networks, because you can be guaranteed that their network is subject to a lot of denial of service attacks that they need to prevent. And as a result, you want to make sure you filter out any packets that could be part of that attack. So I call this slide common sense cybersecurity measures. First one we already talked about, data should be encrypted as much as possible. By the way, please understand that whenever you encrypt, there's a price for you to pay. Aside from the hardware and the software that you need to deploy, the price that you pay typically comes in terms of performance. Encryption does take valuable CPU cycles and RAM. All the stuff has to be done in RAM. So you need to make sure your systems are properly sized, your systems are properly configured to handle that extra load. You keep hearing this multi-factor authentication, or a simplified version of that being a two-factor authentication. Perhaps you're going to send an SMS message to someone, maybe you send a message to somebody's laptop or tablet, and then from there you type that number in, which only you would receive that. Or maybe you receive some kind of a security token. Security tokens, some companies have done away with because they have found out that they're not as reliable. And obviously you want to be able to monitor you should monitor your environment, your network 24/7 to prevent and detect any malicious activity. I can go on for a couple of hours just talking about patching. Patch management has become a full-time job almost. With so much technology, so many software components, the idea here is we want to make sure we have a process in place to install software patches in our test environment and gradually roll that into production. These patches are issued because there have been found loopholes in the operating system, loopholes in application, and as you heard me mention earlier, on the version of firmware that runs on our devices, whether it's IoT devices or any other device. And again, every company, if they don't have it, they're asking for it. They should deploy a formal process to test all this stuff out. As you can imagine, when a software vendor like Microsoft, like IBM, like Oracle, and anybody else issues a software, it's virtually impossible to think about every possible change that could occur that could have an impact on your business critical systems. So you want to make sure you test these so that they do not adversely impact your operation or your instance of the environment. That's why you have to have patching done properly. So what's the best practice for patching? You want to make sure you determine what's the priority of these patches. As an example, Microsoft classifies their patches as critical, important, and optional or recommended. So you need to make a decision based on your security policies, which one of these I want to deploy. First, then you need to test this out in a development environment or in a test environment. And have your application owners come and test their application in a test environment to see are their applications adversely impacted. Then if they say, okay, you install the patches in a live environment in a gradual manner, not everybody at the same time. First of all, if you do everybody at the same time, it's going to take up significant amount of bandwidth on your network. Second of all, it's not going to be controlled, which means if problems occur, then your service desk or your help desk is going to be overwhelmed. And last but not least, after the patches are deployed, you want to monitor the systems to make sure they all continue to work properly. There's also this term that you need to be aware of that's called hardening. A major portion of your operation security has to be to harden systems. Hardening means I am not going to install or activate or run unnecessary devices, unnecessary services, unnecessary applications. A good example. If I'm going to build a server that's going to be web server and it is not going to be an FTP server or email server, guess what? I disable FTP services completely. I disable SMTP service on that machine, and I only run HTTP. If for some reason that HTTP system needs to send email outbound, then I can enable SMTP service. Another important thing is that you only enable ports during the conversation, during the communication. Once that communication is done, you want to block the ports. You also want to make sure you harden your systems by controlling what external devices can be attached. As an example, we can know, because of the advent of cloud-based storage and cloud-based storage that is secure, IBM does not allow us to use the USB sticks anymore. So that's a very important consideration to have. Now, you heard me mention a couple of times about Microsoft Azure, which is Microsoft's cloud offering. How does Microsoft Azure handle hardening? They have what's called Azure Security Center Standard Tier. Through their standard tier, you can typically find and fix security vulnerabilities. You can apply access controls. You can apply application controls. They have an advisor tool that walks you through what you need to do to block malicious activity or detect any threats. And by the way, we usually call this Azure hardening a joint responsibility. Essentially, what that means is the responsibility of the cloud provider, in this case, Microsoft, as well as the tenant, you who are subscribing to that. You want to make sure that in Azure, any keys that you use or any secrets that you use are stored in a component called Azure Key Vault. And essentially, this is where they store all the secrets and confidential matters. You never put this stuff in your source code. Similar to the way you install a firewall for your data center, on-premise data center, you also want to install web application firewalls that can monitor what's coming in, what's going out. And typically, a web application firewall is like a layer 7 device. You want to make sure multi-factor authentication is done, which we have already talked about. Any hard disk files, any virtual hard disk files that are stored, you want to make sure they're properly encrypted along with the encryption keys and secrets and some secret on the appropriate location. And your encryption keys and secrets, you store them in Azure Key Vault. And when you're running VMs, virtual machines in Azure, you want to make sure that they are updated accordingly, if update is your responsibility. Okay. Regulatory requirements add another twist to this whole cybersecurity. Remember, we are responsible for integrity, confidentiality, and longevity of data. Along with that, our governments have come up with their own regulatory requirements. In the United States, these 5 regulations we need to be aware of and we need to abide by. SOX, or Sarbanes-Oxley. Because of events that occurred with 2 companies, namely Enron and WorldCom, now every year, every company that has to disclose financial information, their top management, CIO, CFO, CEO, have to individually certify the accuracy of that financial information. So that means there's no fraud. Health industry, HIPAA. This is a regulation that mandates hospitals, healthcare facilities, and doctors must properly protect patient records, patient medical records, patient treatment information, and only upon the patient's authorization, that information can be shared with a third party. GLBA, which stands for Graham, Leach Bailey, who are the 3 senators who created this act, Graham Leach Bailey Act of 1999, requires financial institutions to explain how do they share the practices to their customers? In Europe, back in 2018, they came up with GDPR, which means customers have to know how their data are going to be shared. And if the data is even being shared, they have to be giving authorization for that to happen. And I have a separate slide coming up next that talks about PCI DSS. And for those of you who are students, you should be familiar with this FERPA, Family Educational Rights and Privacy Act, which means colleges, universities, and secondary institutions must properly protect student records. And if somebody willy-nilly wants to and gain access to your grades, courses you've taken, etc., they cannot do that without prior authorization by you. So what is this PCI DSS, which currently sits at version 3.1, all about? You want to make sure that whoever deals with a credit card industry, whoever is in credit card industry, they have to abide by these measures, these 6 measures. They want to make sure they have built a secure network and secure systems. They can properly protect the cardholder data. They want to maintain a vulnerability management program, how they monitor for vulnerabilities. There are secure control access measures. One measure could be when you call them up, they ask you to enter the last 4 digits of your social security number. Enter the last 4 digits of your card number. What is your last name? Things of that nature, they ask you, what is your zip code? Things of that nature to make sure these before somebody accesses and they can share any information about you. You have to, as we heard earlier, you have to properly monitor your network for intrusion. You can be assured that because credit cards carry a lot of weight these days, hackers are going to go after them. And any credit card company such as Visa or MasterCard of the world, they have to maintain an information security policy. Okay, so here we are, we're now getting to a discussion of firewall. It's very interesting that when you ask people, what's the first thing you have to do to secure your network? People say, install a firewall. Well, guess what? That's not necessarily the first one. First one is establish security policy. Firewall happens to be the network device that is most connected with the idea of security. Firewall can be a dedicated appliance. Firewall can be software or a combination of the two. They can exist as in a virtualized environment, like the way it is in Microsoft Azure or any other cloud provider for that matter, or they can be physical devices. There are various types of firewalls and they reside in various network segments. Packet filtering is probably the most simple type of a firewall, and I talk in more detail about all of these in my course. This is what is called a layer 3, layer 4, which typically only works with what protocols are allowed, TCP and IP, and what port is allowed. Stateful essentially talks about the fact that we want to maintain a table called connection state. And if anybody who tries to connect to you, and if that connection does not exist on that stateful connection table, that connection will be dropped. Proxy, where a server operates on your behalf, acts on your behalf, and sends your data to keep your side of the house private and secret. All is known is just a proxy side. Circuit layer, which deals with protocols such as SOCKS, S-O-C-K-S. We have application layer firewall, which means these firewalls understand specific application syntax, application commands. So that means there is a separate application layer firewall for SMTP, separate one for FTP, separate one for SNMP, so on and so forth. So depending on the type of applications you run, you have to enable or invoke that appropriate application layer firewall. And finally, dynamic packet filtering, which means we do not allow specific packets that do not meet our requirements to go through. And you need to automate this as much as possible and obviously monitor and update and edit these rules as required. Next topic, which is also fairly important, deals with intrusion detection, intrusion prevention. By the way, everything I'm saying to you here, folks, is also covered in a cybersecurity course, which is now part of CompTIA certification process. So material I mentioned to you, even though we're only spending about 90 minutes on it, it's covered at much greater detail within the exam or certification exam that CompTIA has put together for cybersecurity. So you probably have heard of the term Wireshark, which is a packet analyzer. I believe is a open source tool. It helps you monitor the network for issues. Maybe we're doing reconnaissance, and this is what we call ethical hacker, because maybe we're experiencing performance issues. Maybe we're experiencing connectivity problems. So we can use packet analyzers to monitor the network for that. But it can also fall in the wrong hands, and they can use it for reconnaissance and monitoring what's going on in your network. Instead of packet analyzers, which you still can has its own value and its own use, we can use something that's less labor intensive, more automated, to help us more efficiently detect issues. And those are IDS, which is intrusion detection, and IPS, intrusion prevention. The idea around IDS is to detect unauthorized access or unauthorized attacks against our environment. So we want to be able to verify, itemize, and characterize what threats are coming from outside, and oh, guess what? From inside as well. Do not forget for a minute that you cannot let your guards down, because if somebody walks inside your private network, that's all they need. Plug in their network, and then you are halfway there already. So you want to make sure you not only monitor for attacks from outside, you should also monitor for inside as well. And because of this less labor intensive, one example of it is most of these intrusion detection systems are programmed so that they can react in a specific way in a specific situation. Maybe one of the ways they're going to react is that that program is going to get shut down. Maybe the user's connectivity is severed. Maybe we send it, in addition to all of these, we send a message to a central console. Maybe we send a text message to one of their administrators or a group of our administrators. And that's how they're going to detect them, to inform them to understand what has occurred. So from an IDS perspective, event notification, as I just mentioned, as well as alerts. Alerts typically means something that's outside of the ordinary. You have to define what's ordinary. And let's say we had 100 drop packets by our router in the last minute. And if that turns out to be an unusual event, you want to create an alert. Maybe your router is under attack. On the other hand, when we talk about an IPS, its job is to contain the attack, prevention, based on the rules that you have configured. And if you look at this typical architecture, this should give you a general idea of what we're talking about. On the left-hand side, lower left side, we have the big bad internet. Then traffic, as you know, goes through a firewall. And by the way, there could be multiple firewalls here. We have simplified it to just show you here, just a two-legged firewall. Before the traffic can flow to our trusted network, traffic flows in a read-only fashion to our NIDS. Our network intrusion detection system is going to monitor this, and through the databases that are defined in our NIDS management system, we compare it against a database that we know. And if everything looks kosher and clean, then the data can be funneled back to the trusted network. Please understand something very important. NIDS cannot monitor any traffic for internal activity that occurs within the system. So if there is an attack against a system that is carried on by logging onto the local computer that is plugged into that machine, NIDS cannot help you in that situation. You have to have other measures in play. Remember, we talked about a comprehensive network protection. We talked about defense in depth. Here is a good example how defense in depth is going to work. Not only you have to have your IDS architecture, not only you have to have your database of NDIS management updated so that you know what the NIDS traffic we are looking at, but if somebody logs on locally to a system's terminal, you want to have the proper measures in place on that local host to combat any issues. Let's get into the cloud. I believe this should be my next to the last topic. In 21st century, as well as late 20th century, companies no longer store their data just in their own data centers. They have started a shift to the cloud. You hear terms such as software as a service, platform as a service, infrastructure as a service. These are supposed to bring lots of benefits to our clients. So, also cloud provides you with economies of scale. Economies of scale typically means the more you subscribe, the less you pay from a unit perspective, unit cost perspective. Cloud provides on demand. If you've ever you subscribe to services such as, let's say, a Netflix, I only pay for the services I need. Cost savings, switching from capital expenditure to operational expenditures. Why cloud has been so popular? Because no longer I have to have a huge investment on my infrastructure. A lot of those responsibilities are shifted over to the cloud provider. So let's talk a little bit about this cloud security landscape. The best way we can describe this is that it's immature, however, it's emerging. NIST, again, that standards organization within United States Department of Commerce, has published a special publication, you can Google this, 800-144, which talks about cloud security landscape. If you're ever going to be working as a security administrator, if you're going to ever working in cloud, I encourage you to download and review this document. I cover some of it in my 641 course. So as organizations transition to cloud, it's important to understand, demand, and pay for the level of security that is provided in the cloud that's either equal or perhaps better than what you provide in your traditional IT environment. Please understand that if you do not follow proper security protection in the cloud, you could be subject to significant penalties. When I'm saying you, I mean your company, could be subject to significant penalties, loss of business, loss of trust. And the worst way a company can do business is by having them lose, your customers lose trust in your capability of protecting their data. So we want to make sure business customers or a cloud provider is always need to be understanding that their customers are concerned about how is their data segregated. Remember, in a public cloud, the environment is shared. So how do we make sure that this shared data does not leak into a provider, to another tenant? So we want to make sure there's no data leakage. How do we make sure data privacy is preserved? Remember about all those regulations we talked about, GDPR, as well as everything else? How is the data privacy? And every one of these cloud providers, they typically provide you with a list of all the, how they keep your data confidential, how do they process your data, and what do they do with your data. Make sure you read that and understand that. And a lot of customers, understandably, are concerned about how they're going to move their data from cloud back to private data centers. Suppose they decide that, hey, I no longer am interested in keeping my data on the cloud, maybe because my regulations have changed. Maybe I was not happy with the performance of the provider. So we need to find out, if you decide to do that, does that provider keep your data anymore or not? How could business customers move their data from one cloud provider to another? Maybe I got a deal from IBM that knocked my socks off and I want to move away from AWS or Azure. So these are all the things that need to be properly addressed and discussed with the cloud provider. There are 3 specific cloud deployment models that you need to be aware of: public, private, and hybrid. Public essentially means you're operating in a shared environment. And I can tell you from shared, for those of you who have ever heard of server virtualization, that means the cloud provider is going to have this environment where you are be given a virtual machine. That virtual machine runs on a hypervisor. Hypervisor in turn operates on some kind of a server hardware. But from your perspective, you don't know and you don't even care what hardware platform is running, and because the hardware platform is being secured and operated by the cloud provider. However, if you in turn host the environment yourself, because it gives you flexibility, it allows you to set it up based on how you want it, you're operating a private cloud. Private cloud typically costs more because in terms of capital expenditures than public cloud does. But there's lots more flexibility using private cloud. And if your environment operates in such a way, part of your operations are in the public cloud, part of it is in private cloud, we refer to that as a hybrid cloud. Hybrid cloud gives you flexibility. There is trade-off, as you just mentioned, and in interest of time, I'm going to skip some of these. And again, you need to make sure from an infrastructure as a service, platform as a service, software as a service, these are all kept into mind. And I have a separate slide to talk about that. So what is this infrastructure as a service? The vendor or your cloud provider, your CP, provides a hardware platform, provides a data center. You do not need to be worrying about data center. You do not need to worry about cabling. You as the client, you as the tenant are going to install and manage your own operating system, your own applications. The vendor or the provider could charge you different if you're going to be installing, let's say, a Linux operating system on that versus a Windows. And obviously your applications are become your responsibility. So cloud provider provides you access to the data center and maintains access to that data center as well. What is platform as a service? In this example, the vendor is going to not only provide a hardware platform, they're also going to provide a software platform as well. I'm talking about the OS. You, in fact, have no control over the OS, except the platform as a service. Maybe if you're running something that requires a specific OS, then they can give that OS to you. Typically, you're going to hear terms such as middleware, SQL server, web server, Java virtual machine. Those run in a PaaS platform environment. Software as a service, on the other hand, provides you the entire solution: hardware, operating system, middleware, infrastructure, and application. A very good example of software as a service I can provide you is Microsoft 365. So this was extracted from Cloud Standard Security Council, about 10 steps that cloud customers should take to evaluate and manage the security of the cloud environment. And the whole purpose is to mitigate risk. Risk, as long as it's mitigated, as long as it's managed, you will be able to handle your business affairs properly. There needs to be an effective governance model. There needs to be a risk process. There needs to be a compliance process. You need to be able to properly audit your operational processes and business processes every 6 months or a year as your business demands. You have to have a proper place to manage your people, roles, and their identities. Identity talks about what username or process I use to log on. How do I properly protect my data? What are my privacy policies and how do I enforce them? How do I assess security provisions for any applications that are running in the cloud? We make sure that our cloud networks and connections are properly secure. We want to make sure we have proper security controls in our physical infrastructure. It's very important that you understand the security terms in the cloud service level agreements. I can tell you for a fact that as an example, Microsoft Azure provides a minimum of 99.9% SLA for all of their services. Some of them 99.95, some of them 99.99%. You need to understand those security requirements of your exit process accordingly. You heard me mention this defense in depth. What is the defense in depth approach when you move or migrate to the cloud? Again, no different than before, your end users have to be properly trained. They have to have that security awareness. You have to have proper security policies in place. Without security policies, your users don't know what they have to do. They have to be communicated properly to your end users. You have to have appropriate on-premise security. On-premise security can even be talking about having proper cameras in place that can record activities. Have to be having logging systems, people coming with badge. When somebody badges in, is that badge properly logged in? And make sure you meet your compliance and regulatory requirements accordingly. So for cloud security, cloud providers by design provide security for certain elements. I can tell you as a matter of fact, cloud providers typically do not divulge the exact location of where their data centers are for good reasons. They only tell you, like, for example, we are in the East, maybe they might be in Virginia, but that's about it. They don't get any more specific than that. And as a company decides to evaluate cloud services, you need to understand this shared responsibility model. I should have bolded this. This is a very important term, shared responsibility models. Because you need to understand what portion of a security is handled by the cloud provider, what portion of it is provided by the tenant. And depending on whether you're running software as a service, platform as a service, or infrastructure as a service, the responsibilities vary. Typically, data, endpoints, like as in end user devices, user accounts, and access management, these are all retained by a client. So you see, these are 4 very important bullets. Despite the fact that you move to the cloud, you as a tenant still are responsible for these 4. So don't think that everything is down to the cloud provider and I'm off the hook. That does not work that way. I extracted this slide from Microsoft, and that's how the shared responsibility model is handled. Everything that you see in blue is handled by the cloud customer. And everything that's happening in gray is provided by the cloud provider. So you notice the physical security, it gets handled by the client only if you're running an on-prem model, on premises. You have your own data center. However, as you notice, as you move over to any of the 3 cloud models, physical security is a responsibility of the cloud provider. If you're having infrastructure as a service, the host infrastructure is a shared model between you and the provider. Provider gives you the hardware platform, you install the operating system. Network controls the same way. The provider gives you the network devices, physical network devices. You configure the logical network devices. Same thing for identity and access management, client and endpoint, and data classification. So you notice as you shift from on-prem to software as a service, more and more responsibilities shift accordingly. So be aware that just because I migrated to the cloud, again, the cloud provider does have a share, but so does the cloud customer. Okay, I'm going to wrap this up with 2 slides. I would ask you to mark these 3 URLs as very useful sites for NIST, where you can get not vendor specific, but at a high level, what is the United States government recommend and what are the standards that US government has to follow, various government agencies. And last but not least, in this slide, I put together the list of 6 courses, 2 undergrad and 4 grad. And for anybody who's graduating in the undergraduate program, these 2 courses, which are typically taken in the juniors, senior years, are mandatory and required. You need, in fact, to take these 2 courses to understand the more advanced courses. Professor Herbst teaches the MSIS 640, which is Fundamentals of Cybersecurity and Networking Technologies. I have been teaching since 2007 this course, which has evolved over the years. And then there are 2 elective courses that are also offered by GST. With that in mind, I want to thank you for listening to this lecture and then ask my colleagues to open this up for questions.
Thank you, Behrooz, for such a nice
Sure.
presentation. It was really informful and beneficial.
Good.
If anyone has any questions for Professor Khorsandi? If you like also, if you don't get to have questions you don't want to say out loud, you could always email us and we'll get back to you.
And what I can do is Payama will send a copy of this presentation to you, okay, and ask that you share that with the rest of the team for whoever is interested to listen and follow the links especially.
Thank you again. And tomorrow evening we do have at 4 o'clock, we have an ITP workshop. If anybody's interested, please email us. And whoever is interested in the program, in the graduate school, or any of our concentrations, please let us know, Jack Romano or myself. Okay, in the chat, Jim posted the information of Jack Romano.
Again, thank you, everyone. You could always email us or call us. We will be there for you to answer your questions. And thanks again for attending. Have a good evening, everyone.
All the best.
Okay, thank you.
so much.
Bye-bye.